All right, welcome back. We're going to take a brief moment to derive a geometrical result so that we can do a very important application of the squeeze theorem next. All right, so in this discussion, remember if you have the unit circle, so that's a 1 there, this point here, because it's a unit circle, and you come out an angle theta, then the coordinates of this point are cosine theta, sine theta. Okay. All right, so this geometrical result just simply says the area of the following things are in order. One is if you draw a unit circle, draw that horizontal line, you come out an angle theta, and you calculate the area of this triangle. That area is less than the same picture, but now you take the whole pizza slice, the area of it, that's less than or equal to the area. Ooh, can we draw that? Where you grab not only the whole pizza slice, but you keep going and grab a little bit out of it. So this is an angle theta 2. Okay? So the area of these three shapes gets bigger as you go down the line. All right, so let's come up with a formula for these. So that triangle that we had there, if you draw it, remember the coordinates of that point were cosine theta, sine theta. So in other words, the height here is the sine. And of course the base is 1 because it's a unit circle. So the area of the triangle is 1/2 the base times the height. And for this sector, the rule was the area of a sector is the area of the whole circle pi r squared times kind of the percentage of that sector, which is theta all over 2 pi. That's how, for the percentage of the pizza you had, so to speak. The pi's cancel, and so you're just left with a theta over 2 in the middle. And for this last one, you have to remember, again, for the same reason that you had over here, since this point is cosine comma sine, this line here, which is the same part of the line here, has slope sine over cosine. In other words, the slope is tangent. And so the equation of that line is just y is equal to tangent theta times x. So if you plug in x equals to 1 down here, the height will just be the tangent. Anyway, so the area of that triangle will be 1/2 the base, which is 1, times the height, which is tangent theta, which we'll write as sine theta over cosine theta. All right, so we've got a bunch of halves. Let's multiply through and kill all the halves, and we get sine of theta is less than or equal to theta, less than or equal to sine theta over cosine theta. I'm working just with theta bigger than 0 here. You can do a similar argument with negative thetas, and you get the same result in the end. Anyway, these two guys get together and say that if you divide by the theta on both sides, that sine theta is less than or equal to 1. These two guys, if you divide by the theta and multiply by the cosine, you get cosine of theta is less than or equal to sine theta over theta. And so switch in the order here, what you get is this, that sine theta all over theta is bounded by 1 above and the cosine underneath. So this is the geometric formula we needed, and as you can imagine, we're going to be squeezing that one. So, all right, that's it for now. Bye.